Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Okay, so welcome back to our class. Okay, so today we're going to learn a new chapter, okay, which is chapter 10. Okay, gradient of a straight line. Okay, so in this chapter there are only one subtopic, which is 10.1 gradient. Okay, and a few learning standards. Okay, so there are a few word link for you to know, okay, before we look into this chapter. Okay, the first one is steepness. Okay, steepness is kecerunan. Oh, it's typo over here, kecerunan, okay. And then straight line is basically just garis lurus. Intercept is pintasan. Inclination is kecondongan. Ratio is nisbah. Vertical distance is jarak mencancang. Horizontal distance is jarak mengufuk. Gradient is kecerunan. Okay, so why you need to learn this chapter? Okay, learning about gradient will open doors to the careers in mathematics and physics. Okay, true. The formula used can provide exact calculation to problem in project design. Okay, in addition, construction engineers, especially those involved in land surveying, use gradient to determine the stability of elevation of a building area. Okay, and much more actually. Okay, and many more. Why you need to learn this chapter. Okay, so let's look at the first learning standard. Okay, describe gradient and direction of inclination based on real life situation, and then explain the meaning of gradient as a ratio of vertical distance to horizontal distance. Okay, so let's look at this beautiful picture. Cantik comel gambar ni kan. Okay, so steepness and inclination area. Okay, actually you have experienced this in your real life situation before. Okay, so view the picture. Which area is steeper? Why? Okay, so the diagram shows a hilly area traveled by Farid and Afif when they went mountain biking. They found it difficult to continue the ride when they were going up Route C. Tengok, dia kata susah nak mengayuh sekitar A sampai ke C ni. Okay. However, when they were going down Route E, their bicycle moved faster. Why did this situation occur? Okay, saya rasa awak pun tahu kan. This one is more steeper. This one steeper and this one sebab dia naik curam, susah lah nak mengayuh. Lepas tu turun cepat. Okay, itu situasi dia. Okay, so let's look at the first example. Look at the diagram on the side. Okay, compare the direction of the tilt and the steepness of the MN line with KL. Okay, this is MN and this is KL. Draw conclusion from both diagram. Okay, so let's look over here. Okay, for M and P, okay, the stairs, okay, we have the angle of elevation of 30. Okay, and then for KL, we have angle of 45. Okay, let's look over here. The line KL, okay, has a higher inclination than the line MN. Okay, the larger the angle value, the higher the gradient value. Thus, line KL is steeper than MN. Okay, so kita boleh tengok jika angle dia lebih besar, okay, maksudnya dia lebih curam, okay, berbanding yang lebih kecil angle-nya. Okay. Okay, next. Okay, gradient is the ratio of the vertical distance to the horizontal distance. Okay, so what is horizontal and what is vertical? Vertical and horizontal distance. Okay, untuk mudah untuk kita faham. Okay, so horizontal biasanya saya akan beritahu student saya horizontal is x-axis lah. Okay, vertical is y axis. You have learned about coordinate before, right? So it's the same thing, okay? So horizontal, you can imagine the x-axis on the Cartesian plane. And for vertical distance, you can imagine that is y-axis on the Cartesian plane, okay? So let's look at this diagram, okay? The diagram on the right shows children going down a slide at the playground. The length of the straight line which connects point A and point B is 2 meter. Okay, point A, point B is 2 meter. The length of the straight line that connects point C to point B, okay, CB pula, is 3 meter. Okay, so from this diagram, we can conclude that CB is the horizontal distance. Okay, and AB, this one AB is the vertical distance. Okay, boleh kan? Jadi saya cakap, okay, kita imagine this is y-axis and this is x-axis. Sama sahaja. Okay. Okay, let's look at this example. In each of the diagram below, state the horizontal distance and the vertical distance between point P and point R. Okay, so this is point P and point R. This is the gradient. Okay, but we know that the gradient is ratio of vertical and horizontal. Okay, so from this diagram, okay, vertical distance PQ is 2 meter. So this one is 2 meter. Horizontal distance QR is 4 meter. Okay, 4 meter. Next for B, okay, so this is on a grid. Okay, so we can calculate how many units. Okay, so vertical distance RS is, okay, I'm assuming, okay, so we have 1, 2, 3, 4. So RS is 4 unit. Okay, same with PS. PS is 1, 2, 3, 4, 5. So 5 unit distance. Okay, so far so good. Okay, so let's move to the next one. Okay, so from the example, okay, gradient can be calculated as m is equals to vertical distance divided by horizontal distance, where the vertical distance is actually the change in y and horizontal distance is change in x. Okay, let's read tips over here. Okay, m represent gradient of a straight line. Usually we represent the gradient as m. Okay, usually. Okay, next. Okay, example 3. From the following diagram, specify the gradient of the straight line PQ and BC. Describe the steepness of the line PQ and BC. Okay, so the solution. Okay, vertical distance is, what is vertical? Vertical is, we can imagine vertical is y. Okay, axis, so this is y. Okay, so calculate the vertical distance. So 1, 2, 3, 4. So vertical distance is 4 unit, while horizontal distance is x. Okay, 1, 2, 3. So 3 units. Okay, so vertical distance, okay, is equals to vertical is 4, horizontal is 3. Okay, so thus the gradient of PQ is 4 over 3. Okay, remember gradient is okay, a ratio of verticals to horizontal. Okay, still remember you learned about ratio in form 1. Okay, the next, vertical distance. Okay, vertical is y. Okay, 1, 2. So this one is 2 units. Horizontal is x. So 1, 2, 3, 3. Okay, so the gradient is 2 over 3. Okay, please don't confuse. Okay, it's vertical over horizontal, not horizontal over vertical. Most of the time students, they switch this values, so your ratio is wrong, so your value is wrong. Okay, okay, next let's move to the next learning standard. Okay, so far you have any question? No. Okay. So learning standard can derive the formula for gradient of a straight line in the Cartesian plane. Okay. So formula of a gradient of a straight line on a Cartesian plane. Okay. So in Cartesian coordinate system, the gradient of a straight line that passes through 2 points A, xy, y1 and B, x2, y2 can be calculated using the ratio between the vertical distance to the horizontal distance. Same thing as the previous example. Okay. Okay. You can try to complete this table, and then you try to read the discussion. Okay, I'm going to show you a few example. Okay, so let's look over here. Okay, take note of the changes that occurs on each of the straight line. Okay, specify the gradient value for both points. State whether the straight line passes through the origin, parallel to x-axis or parallel to the y-axis. Okay. Before this, you have learned in coordinate chapter, okay, how to calculate the value of gradient, right? Okay. So actually, you can. This one is what we say. This one is you can. This exercise you can try it in your, if you have a laptop. Okay, you can follow this instruction, okay, to see how the ratios changes. Okay, so we can do it manually, never mind. Okay, so now let's look over here, value of gradient. Okay, we know that gradient m, okay, m is y2 minus y1 over x2 minus x1. Okay, so you can label each coordinate. Okay, this one is x1, y1, x2, y2. Okay, so let's substitute the value. So y2 is 9 minus 1 divided by 3 minus 3. 9 minus 1 is 8, 3 minus 3 is 0. 8 divided by 0, cannot write. If you press your calculator, okay, it will come out as math error. So this one is actually infinity. Okay, never mind. After this, I'm going to explain to you what this infinity means. Okay, so next, okay, same x1, y1, x2, y2. So m, so 2 minus negative 3 divided by negative 2 minus 3. Okay, so over here we have 2 plus 3 divided by negative 5. Okay, so this one is 5 divided by negative 5. We have negative 1. Okay, and then over here, let's try this one, m. Okay, 5 minus 5 divided by 7 minus negative 1. So we have 0 over 8. Okay, 0 over 8 is not infinity. 0 over 8 is 0. Okay, and then okay, we try the last coordinate. Okay, m. Okay, 4 minus 4. Sorry, 0 minus 4, for example, never mind, I'm using the positive one. So 4 minus 0 over 4 minus 0. 4 over 4 is 1, positive. Okay, now if you have something with gradient of infinity, okay, the position of the straight line is, okay, parallel to y-axis. Okay, if you have something with negative gradient, okay, your line look like this. Okay, decline, but inclination, dia turun. Okay, if you have something m equals to 0, okay, your straight line is parallel to x-axis. Okay, and if you have positive value, okay, your straight line is look like this, dia menaik ke atas. Okay, so this one you can try it yourself. Okay, so look over here. Okay, identify the straight line, okay, intersecting. Okay, ni nanti from if you have completed this exercise, you can identify. Okay, so we know that m is y2 minus y1 over x2 minus x1, or you can use the intercept form, okay, like the previous example. Okay, so it's actually look like this. Okay, when you calculate m y2 minus y1 over x2 minus x1, it's actually look like this. Okay, so y2 minus y1 is over here. Okay, okay, actually you find the distance of this area. x2 minus x1, actually you find the distance of that area. Okay, this one lah, here. Same thing. Okay, and if you use the intercept form, it will look like this. Okay, okay, let's look at the first example for this subtopic. Okay, determine the gradient of the following coordinate points. Okay, so we have A, B, and PQ. So usually, okay, before you calculate the gradient, we will label the coordinate x1, y1, x2, y2. Okay, you can also label this as x1, y1, x2, y2. Never mind. Okay, it's up to you. Okay, but for this example, okay, I'm going to label it as x1, y1, x2, y2. Okay, so we know that this is the formula for gradient. Okay, gradient is m. Okay, so substitute the value. So y2 is 7 minus 1 divided by 6 minus 3. Okay, so 7 minus 1 is 6. 6 minus 3 is 3. Okay, so 6 over 3 is 2. Okay, just like that. Okay, next. Okay, B. So gradient is m. So y2 is 5 minus, okay, y1 is negative 1. So negative 1 in the bracket. Divide by 3 minus 4. Okay, minus my negative will become positive. So plus 1. Okay, 3 minus 4 is negative 1. So your answer will be 6 divided by negative 1, negative 6. Okay. Okay, next. Okay, determine the gradient of the following points of coordinates. Okay, so this is intercept form. Okay, so we're going to calculate the gradient by using the gradient intercept form. Okay, so from this figure, okay, we know that y-intercept is the point that intercept the y-axis. Okay, so it x-intercept over here, negative 5. Okay, so we know that the gradient for intercept form, okay, you must don't forget the negative sign. Okay, so negative y over x. Okay, so over here negative, so y-intercept is 8, x-intercept is negative 5. Okay, so negative divided by negative will be positive, so your answer is, okay, 8 over 5. Okay, so next for B, okay, y-intercept, y-axis 4. So this is y-intercept. X-intercept is 3. So gradient is negative y over x. Okay, so negative y-intercept is 4, x-intercept is 3. Okay, so remember that I mentioned earlier, okay, if you have positive gradient, your graph will look like this. Dia akan naik ke atas. If the gradient is negative, okay, so your graph will look like this, turun ke bawah. Okay, this is positive m. okay, naik ke atas. Okay, M negatif, dia akan turun ke bawah. Okay. Okay, I hope it's clear for you so far. Okay, now let's try example 6. Okay. Okay, for this example, I'm going to explain something for you. Okay, I'm using this example. Okay, let's look over here. 8. Okay, if you have 8, okay, can you state the coordinate of this point? Okay, so for this point, okay, this particular point, okay, the coordinate is, okay, I know that coordinate should start with x, right? X and y. Okay, so this coordinate is on the y-axis. Okay, so the value of y is 8. Okay, what is the value of x? X, you can look over x. Okay, look at this area. Okay, origin O, so 0. Okay, so we know that each time you have y-intercept, okay, the x value will be 0. The y value will be that point that intersect the y-axis. Same with this point. Okay, this point is on the x-axis. Okay, so okay, the x-axis, okay, x component will be negative 5. How about the y value? Okay, y value, look over here, y. Okay, turun bawah, turun, move lower, pop. Look over here, 0. 0. So the coordinate of this point is negative 5, 0. So from here, you can see that each time you have a point on x-axis, okay, the value of y is 0. So after this, if you jumpa, okay, kalau jumpa coordinate macam ni, okay, the value of y is something and the value of x is 0. So this coordinate is definitely y-intercept. Okay, if you jumpa yang macam ni pula, okay, you only have the value of x and y is 0. So this coordinate is actually a x-intercept. Boleh? Okay. Now, okay, let's look at this example. So you have 2 points, okay, 4, 0, 0, 8, okay. So let's look at L, okay. So L, this is x and this is y, this is x, this is y. Okay, the value of y is 0. Okay, the value of x is 4. Okay, so it means, okay, the x-intercept is 4. Okay, and then look over here, 0, 8. The value is on the y-axis, so this is actually y-intercept. So the value of y-intercept is 8. Okay, so the gradient is negative y over x. Okay, so negative 8 over 4, simplify, negative 2. Okay, remember, every time you write the formula for gradient in the intercept form, don't forget the negative sign. Okay, so let's move to B. Okay, negative 3, 0, 0, 9. Okay, so you write first xy. Okay, now the value is on the x-axis, so negative 3 is x-intercept. Okay, 0, 9. The value, something value is on the y-axis. 0 is x, right? So something that have a value is on y-axis, so that is y-intercept. Okay, so gradient, sorry, y pula, 9. Okay, 9. Okay, so the gradient, okay, intercept form is negative y over 3, negative 9 over negative 3. Okay, so 9 over 3 is 3. Just like that. Okay, simple kan? Okay, next let's move to example 7. Okay, calculate the gradient of a straight line AB and PQ based on the diagram on the right. Okay, gradient, we know that gradient is m negative y-intercept over x-intercept. Okay, so let's look at AB, gradient AB. Okay, this is AB. Okay, so gradient AB, okay, negative, okay, y-intercept, okay, this is y-intercept, right? 2. Okay, so 2 divided by x-intercept is negative 3. Okay, so the gradient is 2 over 3. So we can conclude that the gradient of AB is 2 over 3. Okay, and then for PQ, okay, for PQ, negative y over x, okay, negative, okay, y-intercept is 3. X-intercept is 3 also. So 3 over 3 is 1, so negative 1. So we can conclude that the gradient of PQ is negative 1. Okay. So far 7 example. I hope you understand for each of my explanation. Okay. If you have any problem, you can just comment down below and I will answer it. Okay.